Welcome to another TSE single slider. This time we're looking at webhooks in a nutshell, what they are, how they work, and why they're important. At a high level, webhooks are Stripe's event delivery mechanism, but let's dive into what that actually means. To understand webhooks, we're going to start with Stripe API calls. The Stripe API allows you to do many things like creating payment intents, updating customers, and canceling subscriptions. Those operations are sent to the Stripe API from a user's integration in the form of API requests. At a high level, Stripe's API receives the request, verifies the API key, processes the request, and responds with the result. It's important to note that API operations are driven by the user. They send us API requests when they want something done or when they want to retrieve specific information. But what about when something happens on Stripe's end that the user might be interested in? If something happens as an immediate result of an API request, we can let the user know what happened in the response to that request. But what about other things? Interesting things that happen in Stripe generate events, and those event objects contain the detail users want to know. There's Stripe events for all kinds of things, like a payment intent succeeding asynchronously when authentication is required, a recurring subscription payment failing, or an issuing authorization request. Some Stripe events are directly related to an API request, but many, like these examples, are not. So we can't use the API to tell the user when they happen. So how do users know when these things happen? Enter webhooks. You can think of webhooks like a reverse API. Instead of the user's integration making Stripe API requests, we send event delivery requests, also known as webhook requests, to the user's integration. This allows us to initiate communication from our end when something interesting happens. In order for this to work, two things need to be set up by the user: a webhook endpoint and a webhook URL. A webhook endpoint is an object that exists inside Stripe. It's created using either the dashboard or the API, and it tells us where and how to send events to the user's integration. The most important parts of a webhook endpoint are the list of events to send to the user, the API version we should use to render those events, the webhook URL we should send those events to, which we'll talk about in a moment, and the secret used to sign event delivery requests. The user defines the first three, and Stripe generates the secret. Once a webhook endpoint is created, Stripe will attempt to deliver events to the webhook URL specified. The webhook URL needs to be set up by the user on their end, and its job is similar in many ways to the Stripe API, although the scope is reduced to only receiving Stripe events. The first job of a webhook URL is to verify the event is really from Stripe, not someone else. The last thing you want is to have a malicious person sending you fake Stripe events. When Stripe sends events to a webhook URL, we add a signature based on the webhook endpoint's secret. Only Stripe and the user know this secret, so when the event is received, the user's integration can attempt to compute the same signature using the shared secret. If the signature matches, the user knows the event is from Stripe. That may sound complicated, but our official server-side libraries include functionality that makes webhook signature verification easy. The next thing to do is to save or queue the event for later processing and respond to the request to let Stripe know the event was delivered successfully. A response to the event delivery request with a successful HTTP status code, anything in the 200 to 299 range, tells Stripe the event was delivered. If any other status code is received, or if we get a timeout or network error, we consider the delivery attempt a failure and will attempt delivery again. Stripe has a robust retry system to ensure users will receive the events they care about. In live mode, several delivery attempts are made over several days, so even if the user has hours of unexpected downtime, they should receive the events they missed when they come back online. Finally, the event should be processed. The specific processing depends on the event received and the user's requirements. For example, receiving a payment intent.succeeded event might trigger a fulfillment process on the user's end, while an invoice.payment_failed event may suspend a customer's access to paid services until they pay the outstanding balance due. Note that the order of operations here is slightly different than what happens with the Stripe API. Verification is the first step in both places, but then things diverge. The reason for these differences is that when delivering an event to a webhook endpoint's URL, Stripe only needs to know that it was delivered and saved successfully, but we do not care about the result of processing that event. Stripe needs to deliver a huge number of events to numerous webhook endpoints every day, so we can't spend a lot of time waiting for the processing step to finish in order to get a response back. That means we have a short timeout on event delivery requests, so it's important for users to save the event, let us know they got it quickly, and then do lengthy processing of the event later. Not everyone builds their webhook integration this way, but this is our recommended approach. One final note. There are also Connect webhook endpoints, which can be set up by platforms to listen for events from all of their connected accounts, but that's a slide for another day. So that's webhooks in a nutshell. To recap, you can think of webhooks like a reverse API, where we send Stripe events to a merchant's integration as they happen, just like a merchant sends us API requests when things happen on their side. This makes it possible for users to know when things happen on Stripe's side by receiving Stripe events as those things happen. Many Stripe integrations require webhooks to work properly, and without them, some operations would be significantly delayed, like fulfillment of an order when an asynchronous payment is made, and others would not be possible at all, like responding to an issuing authorization request in real time.